So this is just the intro. This is the summary. The students that I mentioned are listed here at the bottom. So Harshica, do you want to walk us through this, and I'll just change slides when you tell me?
Okay, so the second slide says the goal, where we plan to develop a lateral flow assay based on metal nanoparticles. And we have set like the objectives as first to prepare the nanoparticles using environmental friendly manner. So basically, we plan to use either plant extracts or animal or plant-based milk. And then to do characterization using the normal techniques, those are like the basic techniques everybody does, like using the UV visible, FTIR, scanning electron microscopy. And then we can do the size determination from dynamic light scattering. And Dr. Willson has in his lab 2 other techniques using the ISON instrument and the Archimedes instrument, where more accurate size determination is possible. So after that, the development of the lateral flow assay based on the nanoparticles. So a little bit of background, like people are changing more and more like to be preparing green synthesis methods to get metal nanoparticles. The reason behind that is like it's less toxic, environmental friendly. The most common metal that people have been using is silver, but then silver has its own drawbacks. If the levels exceed, it is toxic. And when in the preparation you use silver nitrate, you have like silver base. That is also toxic. You cannot put it in like aqueous environment. So looking at other metals is more interesting. And if we can find metals which we can prepare green nanoparticles with them, and which can be used for many other applications, that will be the goal. So lateral flow method, I'm kind of new. I have read about it, but it's kind of a specialty to Dr. Wilson's lab. And we watched the first group meeting and what they have done using that technique yesterday. The students involved, I have 2 very good students. One student has worked with me for about 2-3 months. The other person doesn't have much research experience, so all the tasks that we will be planning to do, it's a new thing for them, and they'll get trained on using the instruments that we have at Prairie. So these are the tasks that we have listed right now. Initially, to do the literature search, and then provide reports and presentations, followed by the preparation of the nanoparticles and characterization, and participate in group meetings. Finally, we plan to deliver a lateral flow assay which allows the performance to see particles of various sizes and compositions. Because depending on the starting material, the sizes of the particles will vary. And that's the goal, to have the assay and then how it will work. We have set 4 milestones. First is to prepare develop the method for the preparation, then characterization, followed by obtaining particles of different sizes and masses, because the yields also will vary depending on the starting material. And finally, the development of the lateral flow assay. This is a tentative timeline of the performance matrices. Like initially, the first 2 weeks, we want to focus on the literature search because the topic is new to the two students who are involved in the summer program, followed by the particle preparation and characterization, and the last part, the lateral flow assay and the preparation of the final report. So the way we plan to work is to do the preparation as this was mentioned previously, the particles to be prepared at Prairie, and then some in what, like my experience, like I have been working on this for like about a year now, or a little bit less than a year. You come across different hurdles that where you have to modify the method, and finally to do the precise characterization and the lateral flow assay at U of it. So we have the drawbacks, like, okay, we are going through the COVID-19, so accessibility to facilities are limited. And we, to see, like, you know, when we use other methods, how these will work. In the event like we want to try these other methods, iron, copper, and zinc, to see how it works. If it doesn't work, I have in the lab, like, you know, I had 2 students who worked on the silver project previously, and we have some particles that we have made, and we plan to use that to do the lateral flow assay. So this is a tentative timeline, like, you know, we kind of started on the 18th, so we put it here. I don't know if it's agreeable with the center and how does that work. So that's all I have.